All right,
Okay.
come on, YouTube. So Adrian and I were discussing going live in Norway,
That'd be
Yay.
awesome.
Yeah, that would be good.
and then I was like, I don't know what I'm doing half the time. But he's like, that's okay. I don't either. And I'm like, okay, this could be fun. So we'll see. We'll see if that actually happens or not.
And just watch it. I'm gonna be in Japan and the sun will blow up.
That's usually how it works. I mean,
And
I've
I
been
will
down
see
here for
absolutely nothing.
been down here for like a month, and all this stuff's been happening, and it's like, okay, whatever. It's what it is. Um,
I like the Discover slide.
yeah.
Partial magnetometer data. We're getting
Yeah,
there.
there was some data outages too, right? Or like, well, at least on the Swipsy side from what I saw.
Mhm.
Um, the brief things. But it looks like it came back. So, hi, look, people are here. Yay. Hi,
Yay.
Steve and Justin. I just got the live chat up so I can watch the chit chat. So, as usual, we're going to sit here and talk amongst ourselves for a little bit to give people time to come in here. But you can say hi in the chat or if you have any questions. So, like, hi, Sue. It's fun. I like having audience discussions in here and input. And then just when the cowboy hat disappears, means I'm back up north where I belong, not down here. Luckily the AC works really well in this hotel because it's just too hot. It's too hot down here. I can't deal with it. I don't know how people live down here. I'm probably gonna say that every week, but they do.
That's how I
I
felt
just
about Florida.
Yeah, Florida. Yeah. Except Florida has more of the humid heat.
Yeah.
At least this is as they say, at least this is a dry heat.
So you're being baked in an oven instead of drowning in a swamp.
Pretty much. I should share a picture of the plants at the display because they're all dead. And it kind of cracks me up a little bit. You know, like, hi, Margaret. Yay, everybody's here. All the usual suspects. I love the usual suspects. So
Okay.
I'll chit chat a little bit as they're getting organized here. So we're gonna talk a little bit about forensics and forecasting because as you all have probably been up to speed on, we have five CMEs, but don't get too excited because they're not exactly super big or anything, but we'll get into that. And then going over the data from last week because it's interesting. It's because there were what was it, four CMEs?
Yes.
Yeah. But they all got caught up in the solar wind. So they didn't do there were periods of decent aurora for some people, but it just, they weren't like super, powerful or anything. So that's probably what we're in store for again, something similar. Um, so it looks like we have a decent amount of people here. So we
All
can we
right.
can, we can start this. Let's go.
Okay. You want me to
Yeah, you
drive
can.
up until pretty
Yeah,
much.
you're pretty
Okay.
good at driving these things. So I've just kind of like relinquished that control because every time I do it, I end up showing something not related to anything, and I don't know how I did it.
Ah, it's all right.
Skill.
So
Yeah.
we are, hi everybody. We are still in, yeah, we're still on October 13th. We're
Yes.
behind everybody on the date. Um, Quick updates. Discover is more consistent with magnetometer data. Again, this is rather old, but MAG is available for backup if ACE is kind of struggling, or sometimes you want to confirm that what you see in ACE is really happening. Discover's pretty good. They're not as far separated in the orbit because, again, they're not sitting at L1. They are circling it, and sometimes they are on sort of opposite parts of their orbits, and sometimes are close together. They're fairly close, so it's usable data. Plasma data is also coming, so speed, density, temperature, that's coming sometimes. Um, they're still working on it, and so far it's sort of backup, but not completely backup for ACE. And we are again waiting for Swift L1 to arrive to L1, and it's going to be sometime in January. So hoping for good updates. So far, it's doing rather well in flight.
which is good.
Yeah. So we talked about four CMEs last time. And again, I am at the point where forecasting is really not my favorite part, because we can talk about it forever and the data will look very different by the time it actually shows up. But nonetheless, we talked about it last time. And we talked about solar orbiter being between Sun and Earth and being potentially a pretty good indicator of what's coming our way. And that turned out to be the case. Right now, solar orbiter is more separated from us on a sun earth line. It's about 17, no, not 12. So it's 7 degrees separation. So it's a little higher than us, and it is 12 degrees solar west of us. So it's to the east of us, but well, let's say it's west. And distance is again pretty significant, but because that separation is getting quite significant, it has to be used with extreme caution. And at this point, whatever is coming in terms of the magnetic field, you can't really use it to predict what it's going to look like at Earth because it might be seeing completely different part of the CME. But we saw arrivals, four of them, which was exciting. So one, two, three, four, very small change. So this is
I think we had a
essentially
quick,
close
oh,
to background. And it's a little bump here. So that's one CME, that's another CME, that's another CME. This was a little bit more significant. They were pretty closely spaced because again, they were launched one right after another. And they showed up at some point, somehow. The lines are best guesses really, and this may be one CME, it may be two, this could be one, could be scrunched all together. So those three, I am not entirely certain. So don't take my word for it. If you feel like getting going and correcting it, by all means, I am not firmly attached to this, except this one. This one had a nice jump in total magnetic strength, and it actually did have some sort of magnetic structure. So BZ was south, which generated some nice aurora. Was it anything major? No. -5 degrees, -5 nanotesla, so wasn't really that much, but it was sustained. So it was also sustained throughout here for several hours. So did we see aurora? Yeah. But
mm-hmm.
also, that was the time for full moon. So we didn't see as much as we could, but it was there. Most importantly, only one arrived with some announcement that something is coming. Everything else just increased the magnetic field strength. There was maybe some magnetic structure in here, and that's about it. And that's typical for slow CMEs. They just don't drive a shock. They travel with a regular slow solar wind. They might get a little bit of magnetic enhancement, but you're really hoping to get some negative BZ, but it's not going to be that huge, that significant, or that impressive. And I think we had a little bit of a sawtooth here as a possibility, but again, I'd have to look at the data more closely. And with a full moon at mid latitudes, that was a no-go. People did get it with a full moon. And
Yeah.
of course, northern hemisphere is in the dark. So the typical aurora locations where you do have a season, they're out of the midnight sun. So for them, moon doesn't matter. Moon could be shining in all sky camera and you still see beautiful auroral arc. They're lucky. We're not. So this is sort of big take home that we had last time. We're repeating, I'm just going to repeat it again. When you have this big of a mess of very, very slow CMEs, they probably going to show up without much of a shock. They may not have a sheath. because again, that's an area of solar wind compression ahead of the CME. They typically do have magnetic structure. If it's aimed directly at us, we're going to see the core of that CME. And could it have favorable BZ that's sustained? Yes, it could. Just any regular flux rope, we might get lucky and we might get some negative BZ. Can we predict it ahead of time just because it's slow and sort of launched very, very slowly and traveling with a solar wind that may not really twist and bend and fold it? No. So we have to wait for it to show up. And it's not going to cause severe storming. So widespread aurora, unless you're somewhere in the Arctic, no, not going to happen. You can get some nice aurora potentially extending to mid latitudes, but that's probably the best you can do. So that's it for slow CMEs that we had last week.
Yeah.
And we
Yes.
also had coronal hole. So Mary Beth, do you want to take this one?
The corona hole. Yeah. I mean, so this was, well, like it says here, 84 negative polarity. So we're back into that sector. Um, that's more well, not favorable, I should
Hmm.
say. We're getting out of that because our positive polarity stuff is in the full moon. This is getting in the negative. So it's a lot smaller, and we're gonna get into that because the sun being as active as it is with the active regions actually kind of took chunks out of it. Which
Here.
you can see there. So we get a bunch of little tiny CMEs and then we get a smaller coronal hole. So it's kind of a um like I don't know what to make of this, but we'll see. And it's trans-equatorial. Actually, we're in it because the high speed. I think it was what I saw the highest I saw was 778 somewhere around
Yeah,
there.
it was
770. Yeah.
pushing, yeah, it was pushing 800 and the solar orbiter was showing very similar data. It was showing speed of 800.
Yeah, it's decently fast, and we're still in it right now. It's like 660-ish when I looked at it the other day, or about 10 minutes ago. So we are in it, and the predicted impact of October 11th and 12th, which, yeah, I
That's
would be,
exactly when it
yeah.
arrived.
So therefore, that's our coronal hole.
Yep.
So I guess we can go to the next one. We'll talk about the CMEs that came from that.
Yeah, so not quite because
Yeah,
again,
yeah.
so this is October 10th, and the reason why October 11th was predicted as an as a potential impact, because again, October 10th, you would think it's staring you right in the face, so it might be a little bit too early for that. It had a little bit of
Yeah,
that
a little
horn
tail.
that wasn't completely taken up by the active region. And some prediction was there that it was probably going to be a two-step speed increase. Well, it got more complicated because this is what we got.
Yeah.
So first of all, before any coronal hole, if they're there, we're going to see a sector boundary crossing, meaning one sector of negative polarity and sector of positive polarity are coming together. Magnetic fields don't like to be next to each other because they're going to interact when they're opposite and they're going to annihilate each other. So typically we have a structure that's sitting between them that has a current and has magnetic lines that are extending way out into outer heliosphere. So way, 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 way past Earth's orbit and beyond the sort of outer planets. They do close at some point somewhere. We just can't see it. That's too far away. And same actually happens for kernel holes. Those open field lines that we see as open field lines, they're actually closing somewhere way behind our back. But usually one polarity will switch to an opposite polarity. And sometimes you really see a clear switch from negative to positive. It's one transition and you're done. But sometimes it gets messy like this, where you see multiple crossings. So
Mhm.
looking at BX gives you an idea of when the crossing happened. So one here, then it sort of switched, but then changed its mind, came back. Then it changed its mind again. And finally, well, this is a different structure, finally kind of settled for the opposite polarity. Oh, that was a
Yeah.
tiresome one, but this is all one crossing, and that can happen because, again, that's a streamer belt where one polarity and next polarity, so that's called polarity inversion line on Sun, sector boundary, there it has so many names, but that's where the streamer belt is sitting. So when we have solar eclipse and you see wisps that are coming off the sun, that's a streamer belt. And it can be either pretty much a straight line and the spacecraft's going to cross it once and be done with it, but it can be fairly convoluted. It's mapped as a straight line, but again, we don't really know what it looks like, and it can be very complicated. It often has structures either sort of leading up to the actual crossing or past the crossing. This is probably a small flux rope or just basically a, I'm going to call it small scale structure. It can have a favorable BZ again, so it can generate some aurora and some uh, nice storming. And that's the true about it. And usually you get some enhancement of the magnetic field because again, this is a magnetic structure and it's fairly stable and it's stable magnetic structures can actually hold magnetic field a little bit better compared to this mess. But it was kind of two-step increase. So speed and temperature initially increased to what, about 400, but we knew that was not going to be the end of it. And that probably was that small part because the speed was kind of muted. That small part of coronal hole was sitting fairly far north compared to the equator. Still enough to be effective for us, but not enough to really drive a whole lot of compression of the solar wind ahead of it. But we got some speed increase, we got some temperature increase. Then this structure arrived and it caused both speed to be fairly stable to potentially decreasing until it cleared, and the temperature dropped down a little bit too. And that's pretty typical for sort of those stable um, sort of flux rope structures. I hate to call it flux rope because you can't really tell which way it's rotating,
Right.
how it's spinning, but it's definitely part of something. But then temperature started to increase and speed started to increase. So that's essentially part of that co-rotating interaction region that precedes the onset of fast solar wind, and density started to drop here too. So that was a kind of complex event, and that was, man, that was kind of cool. And sometimes those things are mistaken for CME because it could be a small structure, but with a SIR coming that can create a compression. So CIR, again, it's all about magnetic compression because, again, speed is increasing, temperature is increasing, so it's moving faster. It's kind of compressing this area, and it's going to compress it to create some decent IMF. So magnetic strength is going to be increased. So it can look for all intents and purposes like a CME, but it doesn't behave like one. So that's the only thing. And it could be that sector boundary could be a part of CIR and it could come very close to fast solar wind. It's all about where that boundary crossing happens to be located in relation to coronal hole. So in this case, it was quite some distance actually. So again, this was a bit convoluted. So it was drawn as a straight line, but in reality, it probably is far more complicated than that. And the coronal hole had some distance to it. So spacecraft would have to travel all the to cross all of this before it would get to a coronal hole.
It's fun
Um,
when you can follow the picture with the data.
yes, very much so.
Yeah.
But again, this is where the streamers are located, and this is where the filaments are located. And I think we've talked about it at some point, but if we need to revisit the topic again and talk about it, because we're going to see those structures over and over and over again for the next couple of years as long as we have coronal holes. It gets kind of boring during solar minimum because we don't cross those sectors that often. But right now we have plenty of them. So key feature for sector boundary crossing is really the BX vector change. And it could be very sharp where crossing happens once, but it could be difficult to point out. And retrospectively, you start to see it for scientific purposes. The center crossing, so it can cross many times, but the one that's sort of central is considered okay, this is the boundary. And it typically precedes or comes with CIR and may have some small scale structure with favorable VZ, which is what we want. But you could see a change in all IMF sectors because again, it's switching polarity. So sometimes if the polarity switch comes with switch of just about everything. Everything just reverses. It's fun. I think I have an example of that somewhere. So if you want
Somewhere.
to, we can talk about it. If sun doesn't throw anything our way, that could be the topic all by itself.
Yeah.
And
Lately, that hasn't
again,
been the case,
yeah.
but
So this is what was going on with the CIR. So that's that initial increase in speed. And then it cranked up all the way to actually some 800s and
yeah.
over 800s there. And again, magnetic field compression ahead of it. And once it sort of clears and gets to the cruising altitude, so to speak, it really starts to drop off. And did we get some negative BZ with this unfavorable polarity? We sure did. And it drove some interesting storming. So not a complete waste of plasma, but we definitely didn't get much out of it compared to even this coronal hole previous rotation or the recent positive polarity long coronal hole that just kept going for days, which was very impressive. So, and we're still in
Voila.
fast solar wind. And then the sun started to throw stuff our way. I'm just going to quickly go over the CME, but
Yeah.
Christian, if you want to take over at this point, I do have some modeling data for this one too.
Talk away. It's all yours. You're on mute,
I was
unmute.
pulling up Lasgo to get
Oh,
imagery at least, but there really isn't very much that you can see even in differential imagery.
No.
So Lasgo has very little to look out outside of the northwest puff, which to be fair looks pretty cool still, but
Okay, let me
it's
get
nice to see
out.
the sun
Yeah.
actually doing things. So this is over the
mhm.
period of the last 2 days. We've got the giant northeastern ones that launched, and then there was one that came through that little puff up there. That's one of them. But trying to make out the edges and where exactly the boundaries are is pretty difficult. I'm honestly expecting very small, teeny bumps, if anything, from these ones, even if we get a side glance from them. So to answer that question, Janelle, no, don't. I wouldn't put too much stock into it. Then again, that's always my answer for everything, I feel like. So we don't really have events in the last years that I could be like, yeah, I'm encouraged and actually optimistic about this. No, expect basically bumps, if that at best. I do want to also mention, well, here, let's pull up the actual slide deck too, because I know we have the models up. Most of
I
the
can,
M2M modeling was missed to the northwest, pretty much.
if you want to, I can probably share those slides.
Do
I
it.
have I have more modeling there.
And are they in the slide deck?
Yeah.
Yeah.
So these ones?
Whoa, yay.
There they are.
Yeah. And again, they're all, if you watch the animations, they're tiny little puffs that come out and they almost completely lose any sort of structure by the time it gets to 1 AU. So we have a small mark here. This one doesn't look like it was fully in it. Actually, can this go deeper? No, I can't zoom in on slides themselves.
But there's like, yeah, there's what is that? One that's
Yeah,
got more.
one in Huxt
Yeah.
with a wide distribution of speeds, time, and low probability.
Yeah, that's kind of typical for slow CMEs. All of them are under 600. I think the fastest one, I'd have to go through the slide deck.
I think it was like 589 or something.
Oops.
Yeah, 589 is the fastest one. So we might get a little bit of compression of CMEs ahead of it, but boy,
Let's see,
that's
it
gonna
was
be tough.
433, 416,
Yeah, it's like background level.
505. 448. Yeah, I mean, they're all pretty. Those are speeds you would expect when they get to us after they've traveled, the 150 million kilometers to go. So no hopes on this one. None.
You say that.
That's my favorite part to stay to. Because if I'm wrong, then sweet, I'm wrong, and everyone gets Aurora. If I'm right, then well, it doesn't matter.
Yeah. So you chances are there are gonna be posts about 5 CMEs heading our way.
Mhm.
Yeah.
Should we get
Minor,
excited?
maybe G1, maybe at most war, and the G1 watch would just be because of the compound activity. It's not even like they're expecting it to become anything from that. Real quick too, going over this,
Yeah, there's that
sunspot.
interesting
40,
region.
well, what was it? 44 something or whether.
42,
I've lost
46.
track of the numbers. 42, 46. Yeah. Well, let's get some of the quality back. There we go. And this is it as of at least the most recent pass, but it's finally an actual cool complex one that I think we could very easily see more activity from over the next few days as it approaches the western limb, of course. But we got this nice little negative stream sandwiched in between two positive areas. It looks like it's squeezing it as of now. No real major deltas or anything, but just the whole mix that's in here. It's in growth phase still. So something will come out of it more than likely. So it should make for a wonderful West Limb show.
Oh,
Yeah.
yeah, it's so
That was
close.
optimistic, right?
You're that
Yeah.
ray of sunshine.
Well, and considering that all those
Oh,
CMEs
and
had a very impressive, at least a component of them was yeah, was more of the northwest deflection. So as that area rotates closer to the west limb, we're going to see more and more CMEs that are deflecting. You really need a decent strength to, oh, wow. So,
yeah,
yeah,
look at those pops. I sped it up quite a bit just to get through the amount of frames, but there's two big ones in there. Well, big ones, I guess I should
yeah.
say, quote unquote.
If
But the
you,
major one
yeah,
being here,
if you want to
Yeah,
zoom to
that's
that, because there is actually a
that kernel
very,
wave here.
very coronal wave, and not just coronal
Is it
wave.
going through?
So if you watch it very, very closely, you can see, yeah, it's there, but if you could go back to 211,
You just went normal through
let's
low.
talk about, yeah,
yeah.
let's talk about, so watch very closely what that coronal hole that we just had and we're still experiencing the effects of. Watch what happens as that eruption goes. Yeah, there you go. So there's a coronal hole that's expanding, and part of it is part of the corona is leaving, and there is a transient coronal hole that's forming, but there is also a coronal hole that's southeast of the region. So, yep, that spot right there. So those kernel holes form when CMEs are launched, and you can, to some degree, say you can tell which way which way the eruption is going. So there's probably some component that's going to be going to the southeast of that region and will be accelerated that way. But just look at what happens with that kernel hole.
Isn't that
That's
cool?
That is, yeah, that is really cool. So you can tell the eruption
just
affected.
the
It was a,
blast wave. You can see. I mean, it's really
yeah.
just a good one. Let's see. Bases. Yeah, it's probably too much. Let's see. What time does that really start? I'll say 12:30.
You're just trying to zoom in on that.
I want to do the base differential to see how that looks. But we need to zoom into a closer span of time.
We were joking about this because we are talking about, stealth coronal holes. And I'm like, well, here's kind of that. It just
I mean, the
anyway.
corona is constantly changing when it comes to
uh,
solar max, especially. So what could be closed one pass could very easily
Yeah, it
open the
could be
next.
open.
Yep.
All right,
I
let's
think,
see.
and one of the theories behind what happened a couple weeks ago, where we got that the span of fast solar wind that nothing was
Out of
attributed
nowhere.
to. Yeah.
Yeah, that was fun. Oh
So,
yeah, look at that. There you
Nice.
go.
And that was the case with eruptions today as well. There was also sort of coronal hole that was peeking through. So if you want to look at today's eruptions, they are
Hallmark.
even more northward. Yep, they're even more northward directed today too.
even more northward, even more slower.
At least one was a little on
Of
the
course.
faster side, but hmm, yeah, you really want a few CMEs that are stacked and then one that's pushing all of that together. So that's exactly what happened on May 10th and 11th with all those
Yeah.
eruptions. There was one that was pushing the entire terrain that was
Right,
over a
right.
thousand kilometers per second. But yeah,
But that was
this
some
is
slow
not
brightening.
happening.
It's certainly pretty looking.
And looks like there's another one.
One,
That was way north.
yep,
And we gotta get one more.
yeah.
I mean, it's forming the same way, so I can't imagine it's not, if it hasn't yet, going to fire off again. No, looks like it's settled. There we got some movement there. So I bet we see a flare in the next couple of hours, or
Oh,
at
why
least some
not?
sort of
It's been
eruption.
it's been flaring all along, and it's been erupting all along. Why not? Might as well. It's been busy. It's been working overtime.
Mhm.
That's all I had.
Yep. Well, I guess we can go back to the slide, like, even though we talked about what was in the slides, but we can go back to it. Because we talked about the
Eh.
transient solar hole, or transient solar hole.
Transient solar hole. I like that.
Okay.
I don't know.
Okay.
I don't know what that is, but
So let
We're gonna find
me.
a thing to call it though, because I like that.
yeah, the transient
Yeah,
solar hole.
Transient solar hole.
It's the name of the band that we're
we
gonna form.
we have to. Yeah, we have to call it something probably. So let me find the slide deck. It's not them there anymore. But yeah, we kind of covered most of what's in the slide deck, but I'll just share a few things. So, oh, that's the start of it. I have to scroll through.
Well,
I know. Oh yeah. So, um, of course it's not moving. So, um, transient. Oh, there we go. Come on, don't do that to me.
the transient solar hole
Yeah,
can be seen.
transient coronal holes. They do form following eruptions, probably as a part of the process of eruption, and they accelerate CMEs. They usually close within a short period of time, several hours to sometimes several days. October 10th was a classic. I think it took days to close the coronal hole, that eruption, the X flare, and the CME that was launched on October 8th last year. Really just ripped a whole chunk of it. And it kind of makes tracking of eruptions easier because you know where it is erupting. So there was one that was the eruption yesterday. There was one that was coming from active region itself. Then was one followed by this small area of corona that left primarily northwest, and then this area erupted. So that kind of contributed to the whole thing, and it's kind of cool. Again, this was modeled, but we're way beyond just one model, and it was modeled as two CMEs because one was directed more of the kind of northwest, and one was a little bit more central. So they just decided to do two CMEs for the price of one. Swapesy did the same, and the second eruption, they have it traveling slightly faster, so it's just showing the compression. What's interesting here is M2M decided to model the first one as faster. How it gonna play out, nobody knows. This is just modeling, so this is to try to estimate when it's coming and how bad it can get for the, again, mostly affected industries. Huge window of arrival, mostly because the CMEs are slow, hard to
Mhm.
model them. When they're traveling faster, they're gonna encounter some drag, but it gives them slightly tighter time of arrival. Also, when they're traveling slower, they expand more. They kind of lose some of the power, but even something was not exactly Earth directed by the time CME finally expands because it has more time. It has plenty of time to travel and sort of unravel, and it may finally arrive, but not being very impressive. I mean, last week is a prime example of that. And again, this is what we're dealing with right now, starting with a glancing blow from October 11th to slightly more direct impact with those tiny, tiny wisps from yesterday, and then three glancing blows, slightly more direct glancing blow, and probably more glancing blows. So all of this, the 5 CME stack, this is not May 10th. This is not October 10th. This is not even August. It's more like last week. Something will happen. Something is coming, that's for sure. When, we really don't know. So starting from yesterday, I'm sorry, from tomorrow all the way to potentially October 17th. And when it's going to come is anybody best guess. So don't get attached to the time you see in modeling runs because again, this is just an estimate of when it could come. And the error for slow traveling CMEs is probably even greater. What was interesting in all of those runs, the starting speed at Earth was selected at a lot lower level compared to what we're seeing right now. So the starting speed was probably 350, 400. We're sitting at 600. So those
Yeah.
CMEs probably going to run into fast solar wind. They might be traveling a little bit faster, but because again, density is a little bit lower, they may expand more. And we have seen that when it was a fast CME moving through, even like fast solar wind, it lost a lot of density, and it was still, again, it's all about magnetic field that matters for aurora. If it has some favorable magnetic field, we could potentially see enhancement of aurora for several days out of this. If it's all unfavorable, well, we're stuck. So again, L1 may not be a shock, maybe a small shock, but something is coming. And I think that's the best we can do as far as the forecast.
It's something.
Yeah, exactly.
I
So,
was just going
Space
to
weather be
mention,
space weather in.
yeah, I'm just, yeah, I'm reading the chat because Justin's like, watch it get in the way of photographing the comet. And I was like, oh yeah, I forgot about that comet.
oh yeah. So
Because I don't
yeah,
know how
there.
bright, I don't know how bright it actually is right
I'm
now.
pretty sure it's like still a magnitude 4 or 3. So like it's naked eye level barely with like binoculars, but apparently
Yeah,
you
I've
can see
seen
the
some,
coma quite a bit, but the tail has to be photographed more.
yeah, like
Hmm.
I've seen some decent pictures of it, but it's like, it takes a lot of stacking from what I've seen to pull out the detail. But that was like a week ago, I think. So
There
yeah,
might be some green haze.
yeah. But yeah, to Les's point, I also like going over these events even when they're not that exciting because it just keeps it fresh in your head
Yeah.
and keep thinking about this stuff. So even when it's nothing that exciting, it still makes you like analyze the data and like get used to looking at stuff because you don't like everything. If you don't use it, you kind of lose it. So
And it's all about pattern recognition. So when you
yeah,
start to see that, yeah, those events are rather small and they're slow, it does set some expectation. We still have to wait for them to arrive to really assess them, what's going to happen with Aurora, but at least we know that it's probably not going to be anything major.
right. It won't be what the
It's
Forbes
just
Prediction Center says that we'll see Aurora in
no,
20 days.
no, no.
So that's our competition is the Forbes Space Weather Prediction Center.
Wow, we really haven't had to work much to beat them.
No, it's been pretty good. So I
But
guess
it's kind of exciting because again,
yeah,
we're still in the surge and active regions are still growing. And Sun hasn't forgotten how to do a CME. It can do it, and it can do several in a row.
yeah.
So it's been fun. It's just yeah, we would love to see a major event, but this is not it.
So I was gonna try to make a joke about it, but it doesn't really work the same way. Like yesterday was Sunday fun day, heavy on the sun, not on the fun. I guess that kind of worked here a little bit. Heavy on the sun, not on the fun.
Well, that's
But
okay. But
definitely not a
hey,
sun.
at least we saw some interesting events. I mean, solar
Yeah, we
sector
did.
boundary crossing, telling that apart in real time is really challenging, and it's more clear retrospectively. But when you see some weird data, just chase the magnetic field that's coming with it. You can sort out what's happening to it later, but if it's favorable BZ, don't try to figure out how things will sort of what's going to happen.
Yeah,
If it's dark, if you have clear sky and whatever BZ is coming is enough to drive aurora, that's what you should chase. Definitions become clearer later and you can put a label on it at a later time, but the real-time data is important in real time. And yeah, analysis can be very challenging. And this is like solar sector boundary that we saw is one example of that. It's complicated, it's convoluted, and it's really, I mean, it doesn't help you to chase aurora in that time. It's like it's unfavorable, it's flipping and changing too many times. Yep, it's probably not going to be anything spectacular.
Yeah, just
It's
there you
there. One of those things.
go.
It's there. It's doing something.
There. All right. Well, I think that was the rest of the questions and comments that were in there. Just going back and forth about events of the past. So on that note, I suppose I could let you all have your evening back with a yeehaw.
So enthusiastic.
Woohoo! But as always, we appreciate y'all being here. Y'all starting to work on my southern accent. So anyway, we'll think of, I mean, yeah, well, next week we have the speaker.
Yes, we do.
Yes.
I will be posting it because we actually have Dr. Grandin from Finland who will be talking about
Yes, yes,
different
yes.
auroral forms. So
This will be really fun.
it will be fun.
So that, yeah, I'll be back, so it'll be nice. I'll have my nice setup to do this from, so it'll be cool. So that is next week. So we'll see what happens in between then, here and there. So if you go out chasing comets or aurora, have fun. Um, and we will see you next week. Bye, everybody.
See ya.
I always
Hi.
send, I always